Hi. Well, we're going to finish the last two sections of this chapter, which means then we'll be ready for a test. And in the last section, we talked about adding and subtracting mixed numbers, and you had to get a common denominator. And sometimes when you're subtracting, you have to borrow. And sometimes when you're adding, you end up with an improper fraction and you have to change it to a mixed number. So it's a little bit more difficult than what we're going to be doing today, which is multiplying and dividing these mixed numerals, these mixed numbers. So, which is kind of nice. It's a little easier than the 4.6 when we're adding and subtracting, because, getting those common denominators sometimes it's kind of a pain. So looking at these two here, let's start with number 5. We'll look at some of these. We don't have to look at all of them. I don't want this video to be as long as the last one. That was a marathon. It was way too long. So here on number 5, you're asked to multiply actually an integer 6 times this mixed number 5 3/8. Now the 6 is fine. So what you do if you have a whole number is we're just going to put it over 1. Well, actually, I'm going to transpose. I'm going to transcribe it here. All right, so just a little bit larger, so I can cover that up. Okay, with this integer, we're going to put it over 1. But you have to change this to a fraction notation. So to do that, which is what we did in one of the last sections here, is you take 5 times 8, you get 40, and then you add the 3. So again, just kind of a review, you multiply 5 times 8, all right, you take this number out front times the denominator, 5 times 8, which is 40, and then you add in the 3. So that gives us 43, and you always put it over that same denominator. Sometimes people forget that. They might put it over the 5, or they put it over 1. Sometimes they don't even include the 8, but you do have to include the 8. So again, we put our integer over 1 and we changed our mixed number to fraction notation. And now it's just kind of what we've done before. You reduce. So let's go ahead and we'll reduce. Looks like 2 goes into both the 6 and the 8. So I'll divide this by 2 and I'll divide this by 2. And that's going to be it. So now, the numbers might be a little large, but I think you guys can do this. You multiply across. So now we have 3 times 43, which is 129, over 1 times 4, which is 4. Unfortunately, you're not going to be able to stop here. They're going to want you to take this fraction notation and write your answer as a mixed number. So now we have to go back to a template that looks like this as a mixed number. So we're going to take 4 into 129 and rewrite it as a mixed number. Pencil. So 4 goes into 12 3 times. Bring down the 9. 4 goes into 9 just twice. Well, it looks like we're going to have 1 left over. So we have 32 and 1/4. You put the remainder over the divisor. And there's your answer, 32 and 1/4. So again, just make them fractional notation in any integer over 1, reduce and multiply. This is the only step that we really haven't had to do before, and that's change it back to a mixed number. We've always been leaving them in fractional notation. So, all right, well, let's pick another one and try one. Let's do one with a negative. All right, let's do the one here. Let's do this number 7 here. Okay, so we have a negative 7 and 4/9 times 3/7. Okay, so here we go again. We're going to take this right here and we're going to make it into a fractional notation by taking 7 times 9, which is 63, and you add the 4. So you get 67 over 9. Don't forget over that same denominator. multiply, and then you add. It's a negative, so up to now, I've just kind of ignored that negative. Once you do 7 times 9 and add the 4, don't forget to bring the negative down. Times 3/7. So now I'm going to reduce. Now we've done these before. I'll reduce the fractions and then I'll multiply straight across. So the nice thing about multiplying and dividing fractions is we no longer have to worry about a common denominator. That's only for the adding and subtracting. So now we're going to reduce. 3 goes into here once, 3 goes into here 3 times. So then we're going to multiply straight across. It kind of keeps coming out of focus for some reason. So 67 times 1 is 67. 3 times 7 is 21. Our answer is negative because when you're multiplying and you have one negative, one is odd. If you have an odd number of negatives, the negative stays. All right, so now what we need to do is, unfortunately, we need to change this fraction notation back to a mixed number. So we just multiplied straight across, and you'll end up doing this quite a bit with this multiplication. So we're going to take 21 into 67. And again, our answer will be negative, but I'm going to kind of ignore the negative right now as I get this all set up. So how many times does 21 go into 67? Well, 2 goes into 6 3 times. So let's try 3 and see. So take 21 times 3, you get 63. Looks like it's going to work. That's a weird 3. It's okay. So now we'll go ahead and put a 3 here. 3 times 1 is 3. 3 times 2 is 6. Subtract them. Can't bring anything down, so it looks like we have a remainder of 4. So we have 3, and we take our remainder and put it over the divisor. But don't forget the negative, because that, my math lab will say it's wrong. And you think, what? What's wrong? Well, check and make sure, did I forget the negative in my answer? So there you go. Piece of cake. All right, let's try another one though. Let's do one where let's do number 9. Number 9, it involves a negative. So I know my answer will be negative because I've got one negative, but now we have 2 mixed numbers we're dealing with. So again, looking back at number 5, when I had this 6, I put it over 1. All right. But now, so that happens, that's kind of nice, but here I'm going to go ahead and change. I'm going to, we're going to do number 9 here. We're going to take 11 1/5 times, I'm having a really hard time with making that proportional. Times, because parentheses means multiply. And a lot of times they use the parentheses when one of the numbers is negative. It kind of separates it out, and so that it's not a subtraction, it's actually a negative. So the parentheses kind of makes it multiplication. Otherwise, you might think it was a subtraction. So we have a negative 2 1/2. Eventually, I'll drop that negative and just know that your answer is negative. So I'm going to make both of these fractional notation, reduce, multiply across, and come back to a mixed number. So here we have 11 times 5 is 55, plus 1 is 56 over the 5. Don't forget over this denominator. So you multiply, add, times. Multiply, add. So 4 plus 1, 5. Okay, I'm going to leave that negative off for just a second. Okay, so are there any questions? Well, I guess you guys can't ask questions, but if you do, please contact me. Some of you have been, some of you haven't. I've heard nothing, but as long as you're understanding, that's what's important. Okay, so now that we have made these fractional notation, okay, what we'll do now is reduce. 5 goes into here once, 5 goes into here once. And, looks like 2 and 56 are going to reduce, so maybe this one won't be so bad. 2 goes into here once, 2 goes into 56. 2 into 56. We'll pretend we don't have a calculator. 2 times 2 is 4. 1, bring down the 6, 8. 28. Great, we are not going to have to make a mixed number because when you multiply across, you're going to get 28 over 1. And again, it's negative, and maybe you should keep that negative so you don't forget about it, which is a negative 28. So I didn't have to turn it back into a mixed number using division. It just simplified it out. All right, great. Well, I hope that kind of helps you understand how to do the multiplication. Let's switch to division. So we've done division with fractions. This is pretty much the same. We do have to do a step first, and that is to take any of our mixed numbers and change them into fraction notation. Let's start with number 11. So we have 16. This is a division symbol. I know it might be kind of almost, well, I don't know. You guys can tell it's a division symbol. It's not that bad. Sometimes they look like plus signs. You have to look real close. So, but when you're doing your My Math Lab, it'll say divide. So, you know, it's kind of a no-brainer. So here we have 16 over 1 divided by, I'm not going to change it yet. I'm going to change 1 3/5 to a fraction notation. 1 times 5 is 5, plus 3 is 8 over 5. So I created these two fractions here. I put my integer over 1, and I changed my mixed numeral to fraction notation. Now I still have, because we're dividing with fractions, we're going to do a copy dot flip. All right. Now it's just like the last problems we did. You reduce, you multiply, and if you do end up with a mix, if you end up with a fraction that is improper, then you can change it to a mixed numeral. But let's reduce. 8 goes into here once, 8 goes into here twice. Nothing left to reduce, so we're going to multiply across. We come up with 10 over 1, which is just 10. And we're done. All right. Let's try, let's just try number 12. Two mixed numbers. I'm just going to copy it. So we've got 11 2/3 divided by 2 1/4. So rather than having this one 16 over 1, okay, now I have to make both of these fraction notation. So let's go ahead and do that. So we take 11 times 3 is 33, and you add 2. So you get 35 over that denominator. Divided by, get lots of practice making a mixed number into a fraction notation and then the other way around. So we take 2 times 4, which is 8, plus 1 is 9 over 4. Once you've done that, do not reduce until after you've done the copy dot flip. So 35/3 times 4 over 9. Now, once you've done the copy dot flip, you need to see, can I reduce? Let's see, 3 does not go into this because 3 plus 5 is 8, and 3 doesn't go into 8. And 3 plus 5 is 8, and 9 doesn't go into 8. So we can't use 3 or 9. Neither one of these are even, so you can't use the 4. So it looks like there's no reducing. So we're just going to have to multiply and deal with these larger numbers. So when you multiply across, you'll take 35 times 4. So we have 35 times 4. So 12, 14, 140 over 3 times 9, which is 27. Now what you're going to have to do is, if you stop here, My Math Lab will say, you know, that it's wrong. You need to change that back to a mixed number. So we just have to divide 27 into 140. Well, how many times do you think 27 will go into 140? Well, I know that 20 would go into there 7 times, okay? But I've got a 27, so I might try, well, I'll try a 6. 27 times 6. That's 12 plus 4 is 162. Too many. So let's try 27 times 5. Okay. And you have 35, and that gives you 10, 135. So that looks like we've got it. 5. 5 times 27 is 135. Subtract them, you have a remainder of 5. So again, we just kind of guessed here, just took some guesses. I look at the first numbers and the first numbers to come up with kind of a guess. So it's 5 and 5 over 27. Do we have any negatives or anything in this one? It doesn't look like it. They were positive. Yeah, they were positive. So there's my answer, 5 and 5/27 as an answer. And again, just don't forget to go from here to here. If the numerator is larger, we call it an improper, then you need to change it to here. All righty. Now, if you're looking at number 13, you're dividing 2 negatives. It's 2, which is even. So you know your answer is positive, and you can just totally ignore those negatives. All right, because you know your answer is positive, you can just kind of drop them, make each of these fractions, reduce if you can, and multiply across. Okay, well, that pretty much takes care of that. I do want to look at number 15 here. Let me make sure that you can see it. And then we'll look at a few applications and go on to the next section. Looking at this one here, I've got 12 1/4 divided by -10. And again, those parentheses just kind of separated so you don't think it's a subtraction symbol, but I'm not going to put that in. All right, so the 12 1/4, you do need to make into a fraction notation. 12 times 4 is 48, plus 1 is 49. Divided by -10 over 1. Okay, so again, put your integers over 1. So we took 12 times 4 is 48, plus 1 is 49 over 4. Nice. So now we have these as fractions, and so we're going to do the copy dot flip. 49/4 times a -1/10. It doesn't matter where your negative goes. It doesn't matter. All right, as long as you've got it there. Now you reduce. Now you're ready to reduce. You cannot reduce until you get to this step. Oh, nothing reduces. So because nothing reduces, 7 goes into here, but 7 won't go into either of those 2 numbers. So because of that, we're going to multiply straight across. And we're going to end up with 49 times 1 is 49. 4 times 10 is 40. And I do have that negative, okay, because I have 1 negative and 1 is odd. So that means the negative stays. Whereas in the other one, if you have 2 negatives, they're gone. You can just ignore them because they're gone. Now, once again, this is considered improper. I've got this number, which is larger. So I'm going to 40 into 49 goes once. Okay. So 1 times 40 is 40. This one wasn't so bad. So 1 9/40. 1 9/40. But I do have that negative. I just really want to caution you guys that you put that negative in there, especially on a test. You don't want to go through all those problems and then just forget a negative. Okay, so a -1 9/40. So that's kind of a brief overview of how you multiply and divide using mixed numerals, which really isn't too bad. They're very similar to just multiplying and dividing fractions. Just, remember to reduce, and you don't have to have a common denominator, which is nice. We're going to add a couple of steps now. So here they give you BH and they want you to evaluate this if B is 3 3/4 and the H is 9. Well, they want you to substitute these in right here. Whenever variables are next to each other like that, it means they're going to be multiplying. Whatever the B is times whatever the H happens to be. And those, because these are variables, they could vary, and they have chosen these for the B and the H. So I'm going to put in B is 3 3/4. It's a little bit small. Glad I have another one. So I have 3 3/4 times, okay, the reason I'm multiplying is these two are next to each other, B times H is 9. Okay, so now we go through what we did on the previous page. You make your mixed numeral into an improper fraction. Fraction notation is what your MyMathLab calls it. 3 times 4 is 12, plus 3 is 15. And I'm going to put the 9/1. Now this one you don't do the copy dot flip because it's a multiplication, it's not a division. So right now you can just start to reduce if possible. But unfortunately, there's nothing that goes into both a 4 and then would also go into 15 or the 9. So it looks like we're just going to have to multiply straight across. So we're going to take 15 times 9, which leaves you with 130. About to double check. 4 times 1 is 4. Okay. So, oh, I'm so sorry. It's not 130, it's 135. So it's 135. Sorry about that. But glad I thought about it. Okay, so now then we're going to make this a mixed number. So we're going to divide 4 into 135. Let's see, 4 goes into 13 3 times. 3 times 4 is 12. 4 goes into 15 3 times. 3 times 4 is 12. So it looks like we have 33 3/4. Check the sign, no negatives, we're good. All right, 33 3/4. So again, make sure you check your signs. You might want to make a note when you're taking your test, check the sign so that you don't make, a mistake after you've done all of this work by just forgetting a negative. All right, well, let's look at number 18 here. We have more, we have 3 variables now. So we've added a little bit more to the problem. We're going to take T plus R times S. So the R and the S are being multiplied together. Since those 2 variables are next to each other, you're going to multiply them, and then we're going to be adding the T. So what I'm going to do is I'm going to substitute the values they've chosen for each of those variables. So the T is 4 2/7 plus the R, which is 1 9/14. I hope these numbers aren't nightmares, times the S, which is 6. Okay, S is 6. I'm just going to go ahead and put the 6/1. All right. So once you're to this point, we need to follow our PEMDAS is what we need to do. So in PEMDAS, the multiplication comes first. So these are similar, so I can go ahead and I can multiply. There's no variables left, so I don't have to worry about like terms. But I am going to multiply. So I would not add these two. You have to multiply these two, take that answer and add the 4 2/7. So when you get to this 4.8, there's going to be, I think it's 4.8. Yeah. In 4.8, there's going to be some just review of PEMDAS just using fractions. So let's go ahead and we're going to multiply these two together by first making this a fraction notation. So we have 14, 1 times 14 is 14, plus 9 is 23 14ths. And again, don't forget the 14, why that seems to be a problem, but it happens. So don't do that. So 1 times 14 plus 9 times And I already put my integer over 1. Okay. I'm going to reduce because I don't like to work with any larger numbers than absolutely we have to. So 2 goes into here, 3, 2 goes into here, 7. So when I multiply straight across, 23 times 3 is 69. 7 times 1 is 7. Okay. So now we have 69 sevens. And so you could change that back into a mixed number, because when we add or subtract, we usually just keep it as a mixed number. Okay, now you don't have to, you could change this and then change it back once you get your answer. But since I want my answer as a mixed number, I'm going to go ahead and take this and rewrite it. All I did was multiply, but now I'm going to rewrite my answer. 7 into 69 goes 9. That gives you 63. Subtract, you get a 6. So when I change this, I'm going to get 9 6/7. And this is what I'm going to add to this. So I'm going to take 4 2/7. And I'm going to add, I might move it up a little bit. So that way I can keep the whole problem on so you can see it on the screen. So 4 2/7. Normally, if we're subtracting, I would put the larger one on top, but it doesn't matter in adding. So 4 2/7. And I'm going to add my 9 6/7. And again, I just changed this to here. So when I add these together, oh, great, they have a common denominator. So I don't have to mess with that. So I can just take 2 plus 6. It gives me 8/7. Unfortunately, I'm going to have to create another mixed number here. So we get 8/7. And 4 plus 9 is 13. Wow. So now, again, we're not complete. Now we have to change this into a mixed number. So 7 goes into 8 once. You only do this if that top number is larger. You only do this. 7 times 1 is 7. So 1 1/7. So I'm going to take my 1 1/7, and this is, some people will forget to do this. They'll forget about the 13, and they'll just write your answer as 1 1/7. But you do have to add the 13 and the 1, and you get 14 1/7 as your answer. So you'll take this, which is 1 1/7. This is right here. That's what 8/7 is equal to, and add them, and you get 14 1/7 for your final answer. All right, so it's a little involved, but none of it is really too bad. So we'll review it in the next section. Those will be a little bit harder. All right, so let's look at a story problem or two and see what we've got. Here, Sabrina wants to lay sod in a section of her outdoor space. Her space measures 15 3/4 feet by 11 2/3 feet. So we're going to assume this is a rectangle. And what is the area of the space? So what we have is, I'm going to draw a picture. It's really important in math, and when you've got these story problems, if possible, to draw a picture. Oh, well, I'm sorry. It'll drive me crazy if I don't fix that. So we've got to go straight down. That's better. All right, so here we have 11 2/3. It doesn't matter which side you put the 11 2/3 and the 15. I just thought I'd kind of make it pictorially correct, so I put the longer number with the longer side. And again, make sure, especially those of you going into 1500, that their units match. So again, we've got feet and feet. If they're not feet and feet, you're gonna have to change one of them so that they match. Make them all inches, or make them all feet, or make them all yards, just whatever you need, but they do have to match. So I've got 11 2/3 feet. I'll just use the symbol for feet. Oh, maybe, if I didn't write so hard, I wouldn't run out of lead. Okay, 11 2/3 feet and 15 3/4 feet. Those are symbol for feet. So when I multiply them to find the area, area is base times height, length times width, whatever you want to call those, you know, either one, you're going to multiply them. So I will be taking 11 2/3 times 15 3/4. Oh, fun. So we're going to make them improper and make them fraction notation and then change it back. So 11 times 3 is 33, plus 2 is 35. Boy, I hope some of this reduces down. 15 times 4 is 60, plus 3 is 63 over 4. Well, I can reduce the 3 and the 63 because these two add up to 9, so I know that 3 will go into it. So 3 won't go into that. So we'll just do it into this one. So 3 goes into there once. 3 goes into 6, 23, and 1. All right. Well, that looks about all we're going to be able to do. So you're going to take 35 times 21, 1 times 4. Okay, just to save a little bit of time, I'm going to take on my calculator 35 times 21. Ooh, 735 over 4. And then I'm going to make that into a mixed numeral, go back to a mixed number. 4 into 7, this isn't so bad. 4 goes into 7 once. Bring down the 3. 4 goes into 33 8 times. 8 times 4 is 32. 1, bring down the 5. 4 goes into 15 3 times. 12. That didn't take long. 183 3/4. Put your remainder over your divisor here. And make sure you have units. And this would be square feet. So areas are always square feet, square inches, square centimeters, square meters, whereas volumes are cubic feet, cubic meters, cubic centimeters, cubic inches. But this is area, so it's square. All right, oh, good. Let's look at the next one. Our next story problem, and then we'll look at our last section, 7.8. Oh, excuse me, 4.8. All right, Sabrina wants to lay same one we just did. We will at least do a different one. All right, a car traveled 249 miles on 3 3/8 gallon of gas. How many miles per gallon did it get? Well, the word per, they want you to find the miles per gallon. Per means divide, just like of means time. Oh, yeah, you can see that. Just like of means times in math, of means multiply, per means divide. So we're going to be taking the miles and dividing it by the gallons to find the miles per gallon. A lot of times, if you look at units, units can really help you solve a problem. They pretty much tell you what you need to do. And we'll be looking at that in chapter 9 when we do dimensional analysis. We'll be especially paying attention to units. So miles divided by the gallons. So we take the miles, order matters. So we have to have miles first, divided by the gallons. And there you go. Take the miles divided by the gallons. And here we'll take and put our integer over 1. So we'll change this to a fraction. 10 times 8 is 80, plus 3 is 83. Don't reduce until we do our copy dot flip. Copy dot flip. And then we need to see if we can reduce this. 8 and 3 is 11. So I know 3 and 9 don't go into these. 249. Just trying to think if I can reduce it. Let me see. 249 divided by. Nope. All right. And I know that I can't reduce these. So I'm just going to go ahead and I'm going to multiply across, dealing with some larger numbers, but I have my calculator here. 83. And then we'll just divide that. Oh, it can reduce. This divided by this on my, I just divided it on my calculator. You get 24 miles per gallon. So this would have reduced. 249 divided by 83 is 3. Either way, with the calculator, that's possible. So, my math lab, they use such yucky numbers, but oh well. All righty, that does it for 4.7. We're now going to look at 4.8. Now in 4.8, we're back to practicing the PEMDAS. So here we have some PEMDAS type problems just with fractions. Let's look at this number 5. I have 7/10 divided by 4/5 plus 3/4 times 1/2. In PEMDAS, you do the multiplication and division first before you ever add or subtract. The multiplication and division from left to right. So I'm coming to a division first, so I'll do it. And so whatever you come to, whether it's a division or multiplication, you do that before you would add or subtract. So it looks like I'm going to have to take 7/10 and divide it by 4/5. So we're going to do that. And then we're going to take 3/4 times 1/2. And then when we're done, we're going to add the two results together. So we'll do this one, we'll do this, and then we'll add them together. So here, this is 7/10, copy, dot, flip. So the nice thing is you get to practice some of the ideas that we've done in this chapter. We're going to reduce. 5 goes into here once. 5 goes into here once. 5 goes into there twice. So when you multiply across after you've reduced, because remember in multiplication and division, you don't have to have a common denominator. You reduce and multiply across. 7 times 1 is 7. 2 times 4 is 8. Awesome. Now let's go to our next one. Here we don't do the copy dot flip because it's originally a multiplication. So we're going to reduce if possible. Looking at this, nothing goes into 3. That would also go into 4 and 2. So we're just going to multiply straight across, and we're going to get 3 times 1 is 3. 4 times 2 is 8. And now we're going to add those two together. They already have a common denominator, which is awesome. We don't have to do that. So all we need to do is add the numerators. 7 plus 3 is 10/8. I'm going to reduce it. So here I'm going to reduce this before I make it a mixed number. I always want to work with smaller numbers. I'm going to divide them both by 2. You could have done this after you made it a mixed number, but I want to do it before. So this gives us 5/4. And making it, if they ask, if my math lab, it'll tell you what you need your answer to look like underneath the blank. If they want a fraction notation, you're done. Otherwise, if they want a mixed number, you're going to take 4 into 5. When that's larger, you have to do this step. So 4 times 1 is 4. 1 and 1/4. 1 and 1/4. Oh my goodness. I'm doing well with pencils today. And there's your answer, 1 and 1/4. So again, you just follow the PEMDAS rules. If you've got parentheses, you do that. Then you multiply and divide from left to right, multiply or divide, and then you add or subtract from left to right as you come across that. Okay, looking at this, let's try some harder ones. I'd like to look at number 10. Yeah. let's look at number 10. I don't think you may not have anything this hard on your assignment. We might look at number 9, and then that might be it. Okay, let's look at number 10. So looking at this here, we've got parentheses, we have an exponent, we have a multiplication, and then we have adding and subtracting last. So following our PEMDAS, we'll do parentheses first. So we're going to be taking 3 1/3, and we're going to be subtracting 1 1/2. And then we're going to be squaring that, and say, well, how do you square that result? Well, let's look to see what the result is. So we're going to start in the parentheses first. So we'll be taking, I wanted to cover that up. So we have 3 1/3, and we're going to subtract 1 1/2. Okay, inside the parentheses. Notice that this is larger, the 3 is larger, so I put it on top, and it's positive. The larger one is positive, so I know my answer will be positive. I'm going to get a common denominator. Great review of adding mixed numbers. That common denominator is 6. Okay, now to go from 2 to 6, I multiply by 3 times 3, I'll multiply by 3. 1 times 3 is 3. If this is correct, if you reduce it, you'll come back to the original. To go from 3 to 6, I multiply by 2. So I'll multiply by 2. Okay. So I have 3 now and 2 6 minus 1 and 3 6. Unfortunately, though, this one here, I can't take 2 minus 3. So I have to borrow in order to do that. So I'm going to borrow from the 3, gives me a 2, and I'm going to add 6 6 to that. So I have 2 6 plus 6 6 gives you 8 6. Okay. All right, so I borrowed and I added the 1 to the fraction that I borrowed. So I borrowed this 1, and that's it. The 6 6 is the one I borrowed, and I'm adding it to the 2 6. Minus 1 and 3 6. Which gives us, for our parentheses, 5 6. When you subtract those, let me see, move it up a little bit. 8 minus 3 is 5, 6, 2 minus 1 is 1. So in our parentheses, we have 1 and 5. We still have to square it. Minus 4 times 3/8 is still there, plus 2 and 1/4. All right. So all I've done was what was in the parentheses, and that was pretty involved. I'm going to square it. We're going to talk about how to square it. I still have to multiply, and I'll have to add the 2 and 1/4. All right, so how do you square 1 and 5 6? Well, you're going to have to make it an improper. So 1 times 6 is 6, plus 5 is 11 6 squared. To square this, you square the 11 and you square the 6. Before that, I would try to reduce that if possible, but you can't. So that gives me 121 over 36. Okay, I'm going to leave it like that. We may have to make it a mixed number. We'll see. So we're done. We did the parentheses. We did the exponents. Now we're going to multiply. So I'm going to take 4 times 3/8. And I still have that subtraction there. So that'll be a negative. So I have 4 over 1 times 3 over 8. Okay. 4 goes into here once, 4 goes into here twice. So I have a minus, this is 3/2. So I multiplied plus 2 1/4. So here you've got a choice. You could make this improper and get a common denominator with all three of them. You could do that. You could change these here to a mixed number, and then you could add and subtract. Okay, you would subtract these first and then add the 2 1/4, which is probably what we're going to do. I'm going to go ahead and change these to a mixed number, change this to a mixed number, and then I'll add and subtract as I come to it. All right, so to change this, I don't think 4, probably 3. What's 36 times 3? 108. Yep, that's it. So 3 here, 3 times 36 is 108. You subtract them and you're going to come up with, let's see, 213. Okay. So, and that's all you can do. There's nothing to bring down. So 3 and 13 over 36. That's what that one is. All right. Now we'll change the 3/2 to a mixed number, which really isn't too bad. It's not as quite as involved as this one here. So here 3, I'll do that. 2 into 3 goes once. 2 times 1 is 2. So 1 1/2. Plus 2 1/4. I'm going to subtract here first, get a common denominator, and then I'm going to add this in. So all of this is good practice and review of adding and subtracting and multiplying fractions. So we've got 3 and 13, 36. I'm going to subtract 1 1/2. The common denominator would be 36. Okay, so here this is 18, or no, 8. Yeah, was it 18? Yeah, 18. Multiply by 18, multiply by 18. Multiply by 1, multiply by 1. Wow. So we cannot take 13 minus 18. So we're going to borrow. Oh my goodness, this is very involved. We get 2. I think this covers everything. So here, I'm going to go ahead and copy this. Well, I have room over here. Before I borrow, I want to copy it over because otherwise we just have way too many numbers. I'm going to go back. I'm going to copy it, 3 and 13, 36. That's what I got here. And minus 1 and 18, 36. That's here. Okay. Which means we're going to borrow here and we're going to add 36 over 36, which gives us 2. We have a 2 now. When you add these together, they have a common denominator. You're going to get 49. And you're going to subtract 1 and 18, 36. Now I can subtract them. So when I take this and subtract this, I get 31 over 36. 2 minus 1 is 1. Wow. We still, all we did was we added these 2. We added these 2. This is where we're at. We just added them, or excuse me, subtracted them. And when you do subtract them, you have to have a common denominator, which we did, but we couldn't take 13 minus 18, so we borrowed 1. And that gave us 49 over 36. And now then we have minus 1 over 18 over 36, which leaves us with 31 over 36. Now we can add 2 1/4. So now we're going to add 2 1/4. When I do that, I have 1 31 over 36 plus 2 1/4 is where we're at. I'm going to line them up. Get a common denominator of 36. I have another piece of paper, which is fine. I'll just stick it underneath here so I can carry it through. I'm running out of room. I'm going to make that 36 a wee bit smaller. All right, in order to go from 4 to 36, you multiply by 9. So you multiply by 9. 36 to 36, multiply by 1, multiply by 1. So that's a 3. Kind of gets hard to see that. So we have 1 and 31 over 36. That one didn't change. 2 and 9/36. And we're going to add this time. We're adding that. So we come up with 40 over 36. 1 plus 2 is 3. I'm going to reduce this before I make this a mixed number, because I know that 4 goes into both of those. That's the highest number. So I'm going to divide both of these by 4. So we have 3. 40 divided by 4 is 10. 36 divided by 4 is 9. And I need to make this a mixed number. 9 into 10 goes once. 1 and 1/9. Don't forget, all I did was change this to 1 and 1/9. Don't forget to add in the 3. Add these two together. So you end up with 4 and 1/9. So I just changed it to here. All of these are the same here. So 3 until you have 4 and 1/9 is your final answer. Wow. Makes you love a calculator, doesn't it? That was pretty involved, but that pretty much covered everything. All right. So again, parentheses, exponents, and maybe one of the harder things when we did the exponent was, how do you do an exponent when you've got a mixed number? Well, here, we found this by doing what was in the parentheses, subtracting, and we did have to borrow, but we finished this up, and then to square it, you need to make it look like 11/6. And when you square a fraction, you square the numerator, 11 times 11, and you square the denominator. And then I made it a mixed number. After I multiplied here, I made it a mixed number. So then you subtract and then you add. Wow. All right. So again, that's how you do the PEMDAS. I don't think there's anything really. Oh, yes, there is. Sorry. There is one more thing that I want to talk about before I let you go. Or, maybe we've talked about these. Maybe this has come up. Can't remember between classes what I've talked about and what I haven't. So here, we'll just assume I haven't talked about this. We have 5 halves divided by 3 halves. So this bar right here is a fraction bar. And this is actually called a complex fraction. Here, you can read it here. A complex fraction means you have fractions within a fraction. So I'm going to rewrite this. Okay, I'm going to copy it just so I have a little bit more room. So we have, I just copied it over. We have a fractions within a fraction. This means divide. So I'm going to take the top number, 5/2, divided by 3/2. So both of these mean the exact same thing. So if you're given something like this, you rewrite it like this. A fraction bar means divide. So this and this symbol, these two symbols mean the same thing. And then you can do the copy, dot, flip, and then reduce and finish it up and make it a mixed number if they want you to. All right. So looking at number 12, getting you started here, this is a -2/5 divided by 4. I'll copy it, more room, is a -2/5 divided by, you can put 4/1. You can put your integers over 1. Now I know my answer will be negative, so you can kind of ignore it for a while if you want to, because I've got one negative and one is odd. So once you rewrite it like this, you can do your copy, dot, flip. Okay. And then reduce it and multiply. All right, number 13 here, it's a variable, it's okay. This is t/5 divided by 3/10. So you do a copy, dot, flip. And you'd reduce it 1, 2, and multiply across. So you get 2t. We put your number in front of your variable still, instead of t2, do 2t. 1 times 3 is 3. So that's what you come up with for an answer. All right, so that is just, one complex fraction. There's one more complex fraction. We do these in 9 other classes, like 9:30. Okay, here. All right, what you could do is you could get a common denominator and subtract them. And what it would make it look like this, like one of these here. So you can make it one fraction and then do a copy, dot, flip. Another way to do a problem like this, that you should probably be familiar with, because when you get into more of the algebra, you'll have variables here instead of numbers, is multiply every term by a number that both 8, 4, and 2 will go into. So it's kind of like it's exactly really like eliminating the fractions when you had an equal sign. So you can do that here. We're going to multiply by the number 1. So I'm going to take 7/8 minus 1/4 divided by -1/2. So what I'm going to do is, I know that 8, 4, and 2 will all go into 8. So I'm going to multiply by 8/8. Okay, why can you do this? Why can you just multiply by 8/8? Well, it's going to make it look different, but it's not going to change the value, because 8/8 is the number 1. And if you take the number 1 times a number, it doesn't change the number. It may make it look different, but the value isn't different. 1 times 3 is still 3. 1 times 4 is still 4. In this case, our 1 is represented by 8/8. It's going to make this look better, but it's going to have the same value, because multiplying by 1 doesn't change the value of it. It'll still be the same. It's just going to look different. Now, how do we do this? How do we multiply by 8/8 when we have these? Well, what you could do is you could put an 8 next to each of these. 8/1 times 7/8 minus, I'm just taking 8 times everything. 8/1 times 1/4. It's like you're using the distributive property, 8 times everything. 8 times this, 8/1 times a -1/2. So you can actually write that 8 next to every single fraction individually. And yes, you do have to do it to every single fraction. You reduce them. You're going to multiply here, multiply. So 8 goes into here once, 8 goes into here once. So this first fraction becomes 1 times 7, which is 7, minus this one. 4 goes into here once, 4 goes into here twice. 2 times 1 is 2. That's what that fraction becomes. 8 times a negative 1/2. 2 goes into here once, 2 goes into here 4. Okay. You should always end up with a 1 in the denominator, these little denominators here. 4 times a negative 1 is a negative 4. So this one is a little bit easier to solve than our original. Okay, but it'll have the same answer. We just eliminated the fractions here. So we've got 5 over a negative 4. I don't know if they're going to want you to change this to a mixed number, but you just take 4 into 5 and get 1 1/4. Either one, just whatever MyMathLab wants. Okay, so let's practice 15. Last problem we're going to do for this chapter, for this section. And I'll talk about 16 a little bit, but I think you can get it. Here, I want to get rid of the 6, the 3, the 9, and the 3. All right, so I need a number that 6, 3, 9, and 3 all go into. So while you're thinking about that, I'm going to copy it over. And it's really important to understand this process because in some of your other classes, you may have to use variables and you use the same process, it's just with variables. So with this complex fraction here. Well, I'm hoping that you decided 18. Okay, 6, 3, and 9 all go into 18. So I'm going to multiply every term by 18, and I'm going to go ahead and copy that. I'm going to take 18 over 1 times 1 over 6, because I'm multiplying by 18. So the first one, plus 18 over 1 times 2/3. Okay. We've already done that one, so we don't need to even look at it. So I took 18 times 2/3, 18 times 7/9, 18 times 2/3. I'm going to reduce these four, individually, multiply them, reduce and multiply, and then it's going to be a lot easier than what we had started with. Okay, so let's see, 6 goes into here once, 6 goes into here 3 times. So you're going to reduce individually and multiply. 3 times 1 is 3. I'll put the answer down here. Plus here. Reduce, 3 goes into here once, 3 goes into here 6 times. 3 times 2 is 12. Okay, because you have a 1 on the bottom, you don't have to put 1 there in the denominator. Next, 9 goes into here once, 9 goes into here twice. 2 times 7 is 14. Minus. 3 goes into here once, 3 goes into here 6. 6 times 2 is 12. Okay, now it's really important, and this will be more important when you start your algebra, these 12s will never cancel because when you have pluses, you cannot separate them and cancel. So just, kind of remember that. So you do have to finish simplifying 15 over 2, 14 minus. So 15 over 2, again, they may want you to make that, okay, 2 goes into 15, 7 with 1 left over. Okay, they may want you to make it a mixed number, which we've had plenty of practice doing. All right, last one, I'll just kind of talk you through it. It's a story, well, it's not really a story problem, but it's finding average. To find the average, you would need to add these up, okay, find out what it is, and then divide by 3. And this will be a fraction so that when you divide by 3 over 1, it's a copy dot flip. Okay, so I think you can kind of get that and figure that out. All righty. Okay. Wow. Well, I think that's all, and that's all for these 2 chapters. And then I can get the test opened up for you, and you can finish this one. We're going to do 5 and 6 the next week, and then after that we'll start doing just mostly 1 chapter a week. Kind of slow down a little bit. All right. Again, I encourage you to let me know if you have any questions at all. All right. Bye-bye.